Continuing in 11.4, we're up to example 7. It says, identify the function represented by this power series. Okay, and give its interval of convergence. Okay, so what do we know? We know that e to the x is k equals 0 to infinity of x to the k over k factorial, which means if I replace the x by a 1 minus 2x, I would get it. So this little summation, which we're going to replace, let's see, let x equal 1 minus 2x. So we're going to have k equals 0 to infinity, and we're going to get 1 minus 2x to the k over k factorial would be equal to e to the 1 minus 2x. Okay, so now our interval of convergence has now changed. It would be, oops, that's not how I want to write it. Negative infinity is less than 2x minus 1 because it's absolute value, so I can turn it around. And no matter what you do to this, it's still going to be negative infinity to infinity because you can add the 1, you can divide by 2, still negative infinity to infinity is the interval of convergence. So that was way too easy. Okay, number 8. This power series this is interesting. It says, this power series appeared in the opening section of 11.2. Determine the interval of convergence of the power series and find the function it represents on this interval. All right, wow, this could take a lot of work. Let's see, what can we do with this? Well, let's first, we can get the interval of convergence. We can do the ratio test on this. If you do the ratio test on this, and I don't think they actually did it, they just skipped it all. Yep. When you finish this kind of a problem, let's see, ratio test would give me, let me see if I can scribble it out really fast. K goes to infinity, that's a K. Absolute value, I change all of my k's to k plus 1's, so I have k plus 1 x to the 2 k plus 1 over 4 to the k plus 1 times, flip it over, and then x to the 2k. Alright, so what can I cancel? I can wipe out all of these and leave 1 there. This is really 2k plus 2. So I could wipe out the x to the 2k and the x to the 2k and leave an x squared. So I'm down to the limit as k goes to infinity. I have k plus 1 over 4k. That's a k. And then I have absolute value of x squared. Okay, as k goes to infinity, this thing turns into 1/4 in front. So I end up with x squared over 4. If this is less than 1, it turns into x squared less than 4, which means absolute value of x is less than 2. And if you can check the endpoints, they will both diverge. So the interval is just from -2 to 2, plugging the endpoints back in. Now I've got to find a function that represents that. Okay, so I want to rewrite that summation as, let me see what I can do here. I can pull that k in front and have the -1/4 to the k, those can go together, x to the 2k. Alright, this is going to get a little weird. The problem we have here, we have a k in here. Just this random k. And that's only going to happen if you were taking the derivative of something and the k showed up there, like the derivative of x to the 2k. would be 2k in front, x to the 2k minus 1. So we're going to play a little game here. We are going to stick a 2 inside and a 1/2 outside, so this then turns into 1/2 summation k equals 1 to infinity 2k negative 1/4 to the k x to the 2k. Now we're going to pull 1x out of the series. We're trying to make it match for a derivative. So that would then turn into x over 2, k equals 1 to infinity. This would be 2k negative 1/4 to the k x to the 2k minus 1. Now we need to recognize that this is the derivative of a different series. So let's take a look at that. This would be the same as x over 2, the summation k equals 1 to infinity. I'm going to put the constant first here to make it easier to see. And then it's the derivative of x to the 2k. Because the derivative of x to the 2k would be 2k x to the 2k minus 1. Now, let's combine some stuff and turn this into x over 2, k equals 1 to infinity. Oh, actually, we're going to term by term. We're going to pull the derivative out in front. Let me fix that. X over 2, the derivative of the summation. Plop all this nonsense together. It would be x squared negative over 4, the whole thing, to the k. Now that is geometric. That is a geometric series where r is equal to negative x squared over 4. And so as long as this fits in my interval, so provided that this nonsense, the x squared over 4 is less than 1, which translates to the same thing we had a few minutes ago, absolute value of x is less than 2, we could say that this nonsense up here is equal to it's going to get all sloppy here. Just this piece would be equal to the first term. Now you're sticking in, oh I forgot, k is 1 to infinity. If you stick in k is 1, you get negative x squared over 4, and then 1 minus the ratio, which is negative x squared over 4. And so this problem goes back to, now it is x over 2, the derivative of negative x squared over 4 over 1 plus x squared over 4. Let's simplify this. The derivative of, what does this simplify to? I can multiply through by a 4 and turn this into negative x squared over 4 plus x squared. And now we're going to take a derivative of that, which would be the quotient rule. This is a really long problem. That would be the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared, which turns into x over 2 times, what do we have here? We're going to get a positive 2x squared on the x cubed on the end and a negative 1 in the middle. So I'm going to get a negative 8x over 4 plus x squared squared, which then I could cancel out the 2 and end up with a negative 4x squared over 4 plus x squared squared. Now, looking at this power series, we just made it into a function, and the function would have to be f of x is equal to negative 4x squared over 4 plus x squared squared. And notice it's defined from negative infinity to infinity, but it was a power series, and it's centered at 0, and it only converges from negative 2 to 2, so keep that in mind. And that concludes section 11.4.